Alrighty, folks, we're going to go ahead and get started here. I'm going to start talking a little bit about control heads and how they're wired into the electrical circuit. So let's go ahead and start sharing my screen here for you. All right. All right. So this is one style control. It doesn't mean all the control heads are the same like this one, but you'll notice how it's wired into the circuit. Now, this is not a completed circuit. There's other parts that go into it, but this is going to give you kind of an idea. So if I start off here and it shows me it has an orange wire, I have a connection over here and I have a connection over here and I have a connector over here and I have a connector over here. Now you'll notice these look the same, but they're really not the same because it's going to be a connector over here. It's going to be a connection over to the connector going into the back of the control head. So they kind of lay it out that way. So don't get confused by looking at it that way. But we need to look at the full diagram is what I'm trying to get at before we start saying, oh, no, this doesn't make sense. Because it does, it will make sense as we go along. So I have this fuse over here. This is a heater AC ignition fuse, okay? And it goes down into my control head. Now you'll notice the controller is over here, but I have the fuse over here. So it's just a diagram. So don't get excited yet like that. And then I actually have the blower fuse over here. It's a 20 amp fuse, okay, going in. And it actually is for over here. And then I actually have my last fuse over here is actually this particular one has the directional and it has for the AC on and off button also. So this is just one style. So if you look at it, at the very top, it has the heater AC fuse, 10 amp fuse. Please don't put in a different size fuse. Just put a 15 in there and say everything's good. There's a reason why that fuse burns, the reason why the fuse blows. You need to figure out what that problem is. It could be like a bad control head. It could be a high resistance somewhere in the line. All right, that being said, let's go over to the next little section here. So this is another, okay, so this one actually has pin, okay, B8, okay, so that B8 pin, okay, and then we have the connector C8 over here, and then this actually has it's in circuit 12. See how that lays out? Here's that circuit 12, my orange wire, all right? And if we go back to the previous, okay, I haven't moved yet, but I wanted to kind of show you how it all lays out. So there's going to be a circuit, and when they draw it out on the wiring diagram, this way you can follow it. It'll give you the circuit number, it will give you the connection number, and connector number, I should say, the C8 connector, and then it'll actually tell you what the battery feed is. So my B8, my C4 is my connector, okay? My actually, my fuse, okay? And then I actually have my connector 4 down here, all right? So then if I go to the next slide, it shows me another one. So this is a 20 amp fuse, okay? And then I have a B6 pin, and then I have a C4 connector, all right? And this is on circuit 420. So if you were to look at our full diagram, you could see, okay, this is where it lays out, this is how it goes to control head. And it actually tells you what size wire it is. So this orange, this green, this is all part of that part of that diagram. And then we have another connector. It's the connector shows the top, okay, and it's actually for the HVAC, and it's a 15 amp fuse of it's a particular one, all right. And then this is, it actually is a part of circuit 720. My diagram got cut off here a little bit, but you kind of get the idea of how to look at it at a full wiring diagram. And I'll get you a full wiring diagram as we go along. Again, it shows you what connector, it shows you what pin, pin A10, all this is part of that particular one. It tells you it's a brown wire. So anytime we look at a wiring diagram, we're looking at it from the top down. So you look at power source up top, okay? And then you look at the ground circuit on the bottom. Right, I hope that it helps you. And that's how we look at diagrams. And then we go to the side when we're actually pushing up more parts of the circuit as we go along. Oh, I meant to show you a little bit of that. I'm sorry. Okay, so here my ground side. Okay, so my ground packed right here, or my ground circuit. So you look at the G118. This is what we're looking at. And we're also, the power feeds, like I said before, I kind of got ahead of myself over there. So when we look at the fuse box, or the power distribution box, a lot of times they call it, you'll see a bunch of different fuses. Now you know where to look for when it comes to the different fuses as we go along. So this helps a little bit like that. So this one shows that the junction box, or the power distribution box, and at the pass-through side of the instrument panel. So this one is either under the dash or on the side of the dash, and it shows that it's actually fuse C. So this helps you a little bit because it'll show it in the wiring diagram. Not always do they do it at the fuse panel. So that gets a little kind of confusing sometimes for you too. So you need to look at the wiring diagram. Sometimes it will say it at the fuse panel, but sometimes it won't. This is where one of those things you need to do. And then this one actually shows the junction box, and it's showing where fuse E is at, 20 amp fuse for the blower motor. So here again, here's the blower motor, here's my fuse. And it's going to show that it's fuse E on this particular one. So how does this all come into play? So this actually helps when you're looking at that diagram coming down. And this is just one example, again, showing you how this particular one is wired in. So if I start at the very top, so I know up here is where my power starts down. So here I have my 30 amp fuse on this particular one, and it goes through a blower relay, okay? A blower relay. Now, this is the old style blower relay. Some of the blower relays, or a lot of the blower relays right now are actually electronic, and they can actually adjust a variable speed. The old ones, you had 2-speed, 3-speed, maybe a 4-speed type one, and they were actually a set of different types of resistors inside of it. So this particular one actually is just showing you the blower relay, but it doesn't show you the resistor part of it too, that causes the blower motor to change different speeds. We'll get into that as we go along also. So this is just one style. This is going off to the resistor packed, or it might be the resistor. It could be a resistor, electronic type of resistor pack. Okay, so there's different types out there. So this is just showing the blower motor circuit. So here's my blower motor, and this will actually change the speed over here, and this is just turning it on or off. All right, one of the things that we need to understand, and this is where we can really help us out when we look at the diagrams, because it's going to tell me in my lookup information of what kind of ground, where does the ground go? Because if we have a blower motor that's not working properly, we want to make sure we have good powers and good grounds. And how we do that is by actually visually looking at it. And sometimes we have to do a voltage drop test, which we'll get into as we go along. And so what I want to do is I want to look at the schematic to see where the ground goes to. So this one actually goes to G4 on this particular one. And I'm sorry, it goes down to G118, if you remember correctly on the R diagram before. I was looking at C4 where I started things up. So this one actually on the one we had the diagram before, now we're going to go into another one. This one's going to show me, this is kind of at the visual part of it, and it can be taken off and inspected because we could have corrosion inside of the actual ground circuit here itself because it's out into the elements. And this one actually shows me a ground circuit. This one actually for the cigarette lighter or cigar lighter, power distribution, where I plug in my iPhone or whatever. It could be part of it. And they have an old style ashtray light on this particular way. And then the blower motor and my glove box all have the same ground. And that's what I was trying to lead on to. And this particular circuit has a G122. And that will help me when I have to look up where is that ground at. Now, I will have to look up in a location in my service information, look for my location of my components, and this could be right down inside that also. All right, got a question for you. Once the a faulty ground splice is identified, where is it located? And of course, it's located in the component locator, like I just said a few seconds ago in their service information. And I'll get into that as we go a little more onto that. I'll have a little exercise for you to do on that also. Okay, so troubleshooting circuits, it can be a little bit, confusing at times, but if you take and you break it down, I find it the easiest way to do it. So what I wanted to do is kind of go through a few steps along the way. So first, you want to make sure you talk to the customer and you get a better understanding what the complaint or concern is. I hate to say complaints anymore, but it's concern. So one of the things you want to do is start off like, confirming that it is that the actual concern is happening. Then this is where it gets a little bit hard. When you get some intermittence, say they're saying the blower motor doesn't come on, and then if you talk to them a little farther, well, it doesn't come on all the time, and when I go over a bump, it goes off. So you kind of get an idea of where to start looking. So sometimes you have to take it out on our drive, and the old style ones, systems that actually had a vacuum motor that was attached to them, and it only actually the blower registers wouldn't register when you go up a steep hill because there was a reservoir vacuum bottle that would not have a hole in it, or the lines would be broken and it wouldn't go through the different directions like it should. So getting a better understanding from the customer is the first thing you want to do. So then you want to, if it gets to be more electrical, not more the mechanical side of it, where you're actually going into testing the component, it's a wiring problem. So then you're going to want to get a hold of a wiring diagram. And then you kind of go through a basic understanding of how the system's laid out, and then how do I approach this. So you're going to start off with some basic test points. Am I getting power? Am I going to go to ground? You're going to go out there and do some voltage drops across it. And then you kind of predict what kind of measurements you should have. I know I should have a minimum of this voltage here, and I know I shouldn't have any voltage down here. So this is what you're going to start doing, is kind of laying it out step by step in your head, or you can write it out too, of how I want to approach this. And then you want to, then you want to think on, so basically by getting all your information, getting your measurements down. So you're taking your voltmeter out there and you went through the whole process of checking the different parts. You're going to grab your troubleshooting information, and you're going to look at, does this make sense? Am I okay within a certain amount of voltage, right here? So if the source voltage is within 0.4 of a volt, I should be good. There should be a problem. There might be a problem downstream and upstream. So if I have too much resistance on this side, why am I getting the extra resistance? Is it the blower motors have gone bad? Is it the bad ground, a bad connection? This is all what you're going to do. You're going to kind of lay it out to how does this how does this lay out? And if the source voltage and the ground are good, then you can really kind of narrow it down to a component problem. Is it the blower relay? Is it the blower? Because relays can give you problems too, because they switch back and forth if they're not, if they're old mechanical ones. Could it be a problem with the connections? Could it be a problem with the blower resistor or the blower module? So all these could be part of a problem. So you want to take it step by step. You want to eliminate and then jump in to actually go into the farther parts of the actual component. You don't want to replace a component. It's not bad. You don't want to just start throwing things at it, because that's going to get you in a world of hurt. All right. So hopefully this was helpful. And I will definitely be diving deeper into this rabbit hole as we go along to actually go more into how to troubleshoot these electrical problems, part of the circuit that you are looking at, whether it be a AC problem, whether it be you can use the same approach, whether it be AC transmission, of a light bulb, engine performance problem. All this can be under the same guidelines. So think of it that way, and then we can actually get to the root cause of the problem. All right. We'll be back again talking some more on this. So take care, and I will talk to you soon. Bye for now.